Good morning, students. Welcome back to division physics classes. Today we will start with a chapter rest and motion. Therefore, first we have to know what is rest and what is motion. Now see the board. Rest. An object is said to be at rest if it does not change its position with time with respect to its surroundings. Means you can say an object is said to be at rest whenever the object do not changes its position with respect to time as well as with respect to surroundings. You can take an example. Suppose you keep a book at certain position on your table and on the next day you see that the book remain at the same positions. Means with respect to times and with respect to surroundings the position of the book is not changes. Means you can say the book is at rest position. The book is at rest positions. Now motion. An object is said to be in motion if it changes position with time with respect to its surroundings. Therefore, you can say an object is in motion whenever the position of the object changes with respect to time as well as with respect to surroundings. According to the previous example, on the next day, if you see that the book is not there, means with respect to time and with respect to surroundings, position of the book is changes. You can say the book is in motion. The book is in motion. Therefore, whenever you want to explain the term rest and motion, you have to take the help of surroundings. You have to take the help of surroundings. Means we can say both rest and motion are relative terms. Both rest and motion are relative terms. Now, how can you explain that rest and motion are relative terms? So to explain this, you have to take an example. You have to take an example. Suppose you and your friends are inside the bus which is in motion. At this situation, if you observe your friend, you just see that your friend are at the rest position, But the person who is standing outside the bus, with respect to that person, your friend are in motion. So means your friend at the same time is in motion as well as is at rest. But that motion and rest of your friend, it depends on the position of observer. That's why you can say both rest and motions are relative terms. Now student, in this chapter we have to know about distance, displacement, speed, velocity and acceleration. These 5 parameters we have to know. So firstly, distance. So we have to know what is distance. Now see here very carefully. Total path length covered by an object between its initial and final position is called distance. Means during the motion, the total path length covered by an object from initial to final position is known as the distance. Now see the diagram over here. An object is moving from A to B, then B to C, then C to D, then D to E, then E to F, then F to G. So therefore, during this motion, what is the distance of object? The distance of the object is A, B, C, D, E, F, G. That is a distance. A, B, C, D, E, F, G. Means one thing you take care here that wherever you measure the distance, the direction is not important. The direction is not important. Means the distance has only magnitude, no direction, no directions. That type of physical quantity which have only magnitude, no direction is known as the scalar quantity. That's why you can say distance is a scalar quantity. Distance is the scalar quantity. Next thing, regarding the distance, you have to remember that for the motion of an object, the distance always positive. The distance always positive and never becomes zero. And never becomes zero. Means whenever there is a motion, the distance never becomes zero and it is always positive. It is always positive. Now, whenever any vehicle is in motion, the distance traveled by the vehicles is measured by a device known as odometer. Known as odometer. So these are the important information regarding distance you have to remember. You have to remember. Okay. So therefore, what are the important points regarding the distance? Distance is the actual length of the path covered by an object between initial to final positions. Number 1. Number 2, during the measurement of distance, the direction is not important. So means the distance having only magnitude, no direction. That's why distance is a scalar quantity. For the motion of vehicles, the distance is measured by a device known as odometer. Known as odometer. Next, for the motion of an object, the distance always positive and never becomes zero. Never becomes zero. Now student, we know about the displacement. Displacement. So, what is displacement? The shortest path length covered by an object between its initial and final position. Initial and final position is called displacement. Is called displacement. Means during the motion of an object, the shortest path length covered by the object between initial to final position is known as the displacement. Take the same example over here. A to B, B to C, C to D, D to E, E to F, F to G. But what is the displacement over here? In the definition I say it is the shortest path length from initial to final position. Remember one thing, whatever may be the nature of path followed by the object during the motion, the shortest path length is the straight path from initial position to final position. From initial position to final position. That's why here the displacement is A to G, that straight path that is AG is the displacement over here. So now one thing you have to remember over here very carefully, whenever you measure the displacement, the direction is important. The direction is from initial to final position. Initial to final position means whenever you measure the displacement has both magnitude and direction. Therefore you can say displacement is a vector quantity. Displacement is a vector quantity. Now regarding the displacement, certain point you have to remember very carefully. Just see, displacement may be positive, may be negative, may be zero. May be positive, may be negative, may be zero. Okay. Next point. Magnitude of distance and displacement are equal. See, this is very important. Magnitude of distance and displacement are equal when an object moving along a straight line along the same direction. When an object moving along a straight line along the same direction. See the situation. An object is moving from A to B along a straight line along the direction from A to B. A to B. So therefore here distance is 2 km. Displacement is also 2 kilometers. Okay. Next. Magnitude of displacement is less than distance. Magnitude of displacement is less than distance. When you can say, when an object is moving such a way that during the motion the direction of the object is changes. The direction of the object is changes. Okay, then you have to remember displacement is always less than the distance. Displacement is always less than the distance. See the situation. An object is moving from A to B, then from B to C, then from C to A. Okay, so now initial and final position of the object are same. So in this type of motion, what is the distance? Distance is 4 kilometer plus 3 kilometer plus 2 kilometer, that is 9 kilometer. But as the initial and final position are same, the displacement is 0. The displacement is 0. So from this example we can say the displacement is always less than distance whenever the direction of motion is changes. Okay. Now student, lastly, distance and displacement, whenever you measure, you have to measure in terms of length. That's why both the quantity have the same unit. In SI their unit is meter and in CGS their unit is centimeter. Okay, so student, go through this video very carefully. If you face any problem, you can contact with me. Thank you.